Hi everyone. In this video, we'll learn what is open channel flow. What are the difference between the open channel as well as the pipe flow? What are the different classifications of open channel flow? And what are different geometrical properties of the open channel flow? Okay, so first let me understand or let me tell you what is an open channel flow. See, in open channel flow, the water flows under atmospheric pressure. Open channel flow, it is the passage of the water which flows under atmospheric pressure. So, but in case of the pipe flow, since it is an closed flow, that is the pipe flow will nowhere will subject it to an atmospheric pressure. That is a major difference what an open channel as well as the pipe flow. So let me understand the difference between the pipe flow as well as the open channel flow. So I'll consider a pipe of the any cross section. So this is the pipe I have considered. Okay, so this I'll consider the direction of flow, that is the velocity with the velocity v. See, what happens is in this pipe flow, usually it is an very first difference is the pipe flow is pressure flow. Okay, so if I consider an open channel on the other side, so this is the channel bed. Okay, so this is the bed of the channel. So this will be the water surface. This is the water surface. This will be the depth of the channel. I take the depth as the D. So this is the open channel. This is the pipe flow. It is a pressure flow. So this is the direction of flow. Whereas the open channel flow is gravitational flow. Open channel flow is what? Gravitational flow. Okay, this is the first and the important difference. What we have, this is pressure flow. This is the gravitation flow. And so since the pipe flow will not have a free water surface will not be there in the pipe flow. I want to get a pressure at the various points of the water surface. I have to connect an piezometer. So I'll take the two sections. Okay, so I'll connect a piezometer. You consider this is the level of water in this piezometer. This is the level of this water in this piezometer. If I join the water level of the piezometers, different piezometers, you can consider n number of piezometers. This line is nothing but an hydraulic gradient line. So hydraulic gradient line in case of the pipe flow is obtained by line joining the piezometric head, which is connected at the different section. Whereas in case of the open channel flow, the water surface itself is the hydraulic gradient line. Okay, so next, if I add the velocity head to this hydraulic gradient line, I'll get what? The total energy line. Okay, so this total energy line is at a distance of the v square by 2g. So if I add velocity head to the hydraulic gradient line, I'll get an total energy line. Here also the total energy line is obtained by adding the velocity head to the hydraulic gradient line. So this is the second difference is hydraulic gradient line. Okay, is the one which is obtained by line joining the head of water at the different piezometers at the different section, whereas hydraulic gradient line is nothing but an free water surface. Free water surface itself is the hydraulic gradient line. The next third difference is the total energy line is obtained, that is, our total energy at any point in a pipe flow is obtained by sum of the pressure head plus velocity head plus datum head. Okay, whereas in case of the total energy line or the total energy in case of the open channel is nothing but specific energy, which is depth of the flow plus the velocity head v square by 2g. So this is nothing but the specific energy equation. So we'll derive this equation later. Okay, just understand the total energy in case of open channel is nothing but the depth of flow. Okay, this is the depth of the channel or depth of flow plus that is velocity at v square by 2g. If I add these two, you'll get what? Total energy in case of the open channel flow. This is the third difference. Next, the fourth difference is since pipe is having an uniform cross-sectional area or the cross-sectional area of any pipe is fixed. Cross-sectional area is fixed. Whereas in case of open channel, which will be having an different cross-section at the different length, it will be having a different cross-section. Because for example, you can take the example of a river. So river is a natural open channel, okay? River, or what we call it as a stream, anything will come under this open channel. It doesn't have an fixed cross section, okay? Whereas in pipe flow, it is a fixed cross section, okay? Next comes the fifth difference is in pipe flow, the pressure difference between any 2 points. Say, for example, I need a pressure difference between these 2 points. Since it is not having any free water surface, the pressure difference between any 2 points can be obtained easily. Okay, so the pressure difference between the 2 points can be found. Okay, so in case of the pipe flow. But since the free surface of water is same throughout, it is subjected to the atmospheric pressure only. So even if I take at this point, it is atmospheric pressure. Even if I take at this point, it is atmospheric pressure. The pressure difference between 2 points can't be found because all the points will be exerted, will be having an the atmospheric pressure only. Therefore, pressure difference is not possible between any two sections in case of open channel flow. These are the important 5 different differences you can write in order to understand the difference between the pipe flow and the gravitational flow. Also, you can write that the frictional resistance is less in case of the pipe flow, whereas the resistance is very high in case of an open channel flow. These are the important difference between the open channel as well as the pipe flow. Now we'll see what are the different classifications of open channel flow. As in case of pipe flow, this open channel flow is as classified as an number based on number of parameters. The first and the very important type of classification is steady flow, steady and unsteady flow. Okay, steady flow and unsteady flow. A flow is said to be unsteady when the different flow characteristics like depth, or the velocity, or the pressure, okay, will not change with respect to time. That flow is called as steady flow. Means the depth, if I take depth as d with respect to time, will be as constant. Then the flow is called as steady. Similarly, you can write the velocity with respect to time or the pressure with respect to time is equal to the constant. This type of flow is steady flow. So steady flow is the one where the flow characteristics like depth, velocity, pressure does not varies with respect to the time. That flow is called as steady flow. In case of unsteady flow, a flow is said to be an unsteady when the depth flow characteristics like depth or the velocity or the pressure, okay, if it changing with this or if it is not constant over a particular length, then that type of flow is called as unsteady flow. So unsteady flow is the one in which the flow characteristics like the depth, the velocity, pressure, etc. will change with respect to time. That flow is called as unsteady. This is the first classification, steady flow, where the depth, velocity, pressure is constant with respect to the time, whereas in unsteady flow, which is the depth, velocity, and pressure is not constant with respect to the time, that flow is called as unsteady flow. The second type of classification is uniform flow and non-uniform flow. Uniform flow and non-uniform flow. Usually is a non-uniform flow is also called as varied flow. Okay. So in case of uniform flow, the various flow characteristics like depth, velocity, pressure, okay, etc. will not change or it is constant with respect to the length of the channel. That type of flow is uniform flow. If I take the depth with respect to the length, or we can take it as with respect to the spacing, if it is constant over a particular length of the channel, that flow is called as uniform flow. Where in case of a varied flow or non-uniform flow, the different flow characteristics like velocity, pressure, etc. which is not constant for a particular length of the channel, then that type of flow is non-uniform flow, whereas the depth, velocity, pressure will not be same over a particular length of the channel. That flow is called as non-uniform flow, or the varied flow, what we call it as a. So in varied flow also we have two different types. One is a rapidly varying flow, another one is gradually varying flow. In rapidly varying flow, where the depth of the channel will be changing rapidly or abruptly, that type of flow is called as a rapidly varying flow. So we usually call as a rapidly varying flow, or VF. The another one is gradual varied flow, where the depth will varies gradually. So in case of rivers and the streams, you can experience the rapidly varying flow. You can take an example of the flow through rivers. It is a rapidly varying flow. So what is uniform and non-uniform flow? If the flow characteristics of the channel will be constant over a particular length, then it is called as uniform flow. In case of flow characteristics is not constant over a particular length of the channel, then it is called as non-uniform flow. In non-uniform, we have rapidly varying and the gradually varying flow. Rapidly varying means the depth will change abruptly, whereas gradually varied flow, the depth or the other characteristics will be gradually varying. That is the second classification. Now we'll move on to the third classification. Third is laminar and turbulent flow. Lamina and turbulent flow. Same in case of pipe flow, the flow is said to be laminar or turbulent is decided based on an dimensionless number, that is Reynolds number. Reynolds number, which is usually given by an equation, that is rho v r divided by mu, where rho is mass density, v is average or the mean velocity of flow in open channel, r is hydraulic mean depth. This hydraulic mean depth we'll discuss in the next section, whereas mu is the dynamic viscosity of the flow. If this Reynolds number less than 500, then the flow is laminar. Okay. If this Reynolds number greater than 2000, then the flow is said to be turbulent. If the Reynolds number lies between 500 to 2000, then this flow is called as transitional flow. Okay, so this is about the laminar as well as the turbulent flow. That is dependent on the Reynolds number of the channel, that is rho VR divided by mu. So if it is less than 500, it is laminar, greater than 2000, we call it as a turbulent. If it in between 500 to 2000, it is called as transitional flow. Then the fourth type of classification is critical flow, subcritical flow, and supercritical flow. Okay, it is an critical flow, subcritical flow, and the supercritical flow. See, as we know that in an open channel, the gravitational force is very predominant. Correct? Gravitational force is very predominant. Therefore, based on the gravitational force and the inertial forces, what we can get a number called another dimensionless number called as Froude's number. Okay, so this Froude's number, which is given by the equation v divided by square root of g into d. So this Froude's number as well as the Reynolds number already we discussed in the previous videos of dimensional analysis as well as the model analysis. We have discussed this to Froude's number as well as Reynolds number. In this, whereas v is the velocity of flow, g is acceleration due to gravity, and d is hydraulic depth of the channel. Correct? If this Froude's number works out to be 1 or equal to unity, flow is called as critical flow. If this Froude's number less than 1, which is called as subcritical flow. Okay. If the Froude number greater than 1, which is called as supercritical flow. Okay. So this, since the flow is said to be critical, subcritical, and supercritical, will be dependent on the Froude's number. There is a dimensionless parameter Whereas since the gravitational force is very predominant in open channel, this is the fourth type of classification, what we call that is the critical, subcritical, and the supercritical. These are the four different classifications of open channel flow. We'll see what are the different geometrical properties of the channel. The first geometrical property of the channel is depth of flow. The first geometric property is depth of flow, which is usually denoted by the letter small d or y. Okay, so it is an vertical distance between the lowest point of the channel. It is a vertical distance between the lowest point of the channel to the free surface. That is the depth of flow. The second one is wetted perimeter. Wetted perimeter, which is denoted by the letter P. The wetted perimeter is the length of the channel in touch with the water. It is, or the, we can call it as the total boundary of the channel, which is in touch with the water, is called as wetted perimeter. It is the total boundary of the channel in touch with the water is called as wetted perimeter. The unit of wetted perimeter is meters. Okay. The third one is wetted area. Wetted area, or we can also call it as an cross-sectional area of flow, or the area of flow. It is denoted by the letter A. Though the wetted area is defined as nothing but the cross-sectional area of flow normal to the direction of flow. It is a cross-sectional area of flow of the channel normal to the direction of flow. Normal means perpendicular to the direction of the flow. That area is called as wetted area, or we can call it as an flow area or the area of the flow. The unit is meter square. Okay, the fourth property is very important one, that is hydraulic radius. Hydraulic radius, or which is also called as hydraulic mean depth. Hydraulic mean depth is usually denoted by letter capital R or small m. Okay, the formula for this hydraulic radius or hydraulic mean depth is given by, that is m is equal to the ratio of cross-sectional area of flow to its wetted perimeter. M is hydraulic mean depth, is defined as the ratio of cross-sectional area of flow or the wetted area to the wetted perimeter is the hydraulic radius. The unit is also meter, because it is a depth. It is also an hydraulic mean depth. Next, the fifth geometric property is hydraulic depth. Hydraulic depth. The hydraulic depth is usually denoted by the letter capital D. Capital D. It is defined as, hydraulic depth is defined as the ratio of wetted area to the top width of the channel. Ratio of wetted area to the top width of the channel is called as hydraulic depth. Okay, so then the sixth one is top width. Top width, it is denoted by letter capital T. The top width, the T, is the width of the channel at the free surface. Top width means, as the name indicates, top width. The width of the channel at the free surface is called as top width. Next, the seventh geometric property is section factor. The seventh property is section factor. It is usually denoted by letter Z. The formula or the definition of the section factor is nothing but an product of, it is the product of wetted area and square root of hydraulic depth. Section factor is the one, it is defined as the product of cross-sectional area of flow or the wetted area and square root of depth of flow is the section factor. Okay, so it is section factor is for the critical flow computation. Okay, it is mainly for to find the critical flow computation. These are the important 7 geometrical properties of a channel. Say this is the depth of the channel is D, wetted perimeter is P, wetted area is A, hydraulic radius or hydraulic mean depth is M, hydraulic depth is capital D, top width is T, section factor is Z. Okay, so in order to understand these geometrical properties, let me take an example of any channel so that I can write all the 7 parameters of that channel. There you can understand in a better way. Let me take a rectangular channel. This is the rectangle channel. This is the free surface of the water. Free surface of the water. So I'll consider this B as width of the channel. The depth of the channel I'll consider as Y. Okay. So this T I'll consider as a top width of the channel. Since the rectangle channel, it is base width, which is equal to what? Top width. So let me tell you, the depth of flow is Y only here. So this is Y. Now comes the wetted perimeter. So depth, it is Y, the first property. The second property is what? Wetted perimeter P. Wetted perimeter P, as I told, it is a channel boundary in touch with the water. Now, since it is an rectangle, so this is the water complete. The channel boundary, if I take, which in touch with the water is, if I start from this point, free surface, this is the one that is channel boundary that is in touch with water, that is Y, plus from ear to ear, it is in contact with water, B, plus this is Y. Therefore, wetted perimeter works out to be B plus 2Y. Understood? Next, third one is area, that is wetted area A is equal to, since it is a rectangle, it's a cross-sectional area, width multiplied by depth, B into Y. Next, the fourth one is hydraulic radius or hydraulic mean depth, that is M is equal to A divided by P, which is equal to A is B into Y divided by wetted perimeter is B plus 2Y. Next, the fifth one is hydraulic depth D, which is nothing but, that is area divided by top width, area divided by top width. What is the area? It is B into Y. Top width, you observe the figure, the top width is nothing but B only. Top width of the rect, since it is a rectangle cross section, the top width is equal to the bottom width, that is B. The T is can be written as B. So B with B cancel. The hydraulic depth works out to be Y. This 2 will cancels. Correct? Next, the sixth one is top width. As I told earlier, top width is nothing but B only. Okay. The seventh one is section factor. Section factor, Z is equal to area. So I'll write the formula first. Okay. That is area into square root of hydraulic depth, which is equal to area as B into Y. Then square root of D is hydraulic depth. Hydraulic depth is Y. Okay. So B into Y into square root of Y, or also you can write which is equal to B into, this is Y to the power of 1. This is Y to the power of half. 1 plus half, it is to the power of 1.5. Okay. So this is how you can write the different geometrical properties for an channel that is mainly dependent upon the cross section of the channel. First, you have to decide what is the cross section he has given. Cross section might be an rectangle, trapezium, circular, triangular, like that you'll get different cross section. Based on that, you can write the geometrical properties. Okay. Thank you.